Can you see my screen?
Yeah, your screen is visible. You can start.
Yeah, okay. So, hi everyone. I'll present my project here. It's basically called ChurnAlert AI, which is a decision-centric agenting system that is involved in a SaaS business. So, today we'll be covering problem statement, what motivated me, what is the background behind this project, the approach, design, implementation, and how the data was collected, analysis, and what was the actual findings from my project. So, the main research question here was like if AI system can already predict uh, which customers are going to churn and why they basically fail to guide what to do about it. So basically, the existing prediction tools were able to tell only which customers were at risk, but they weren't able to actually predict who they should contact or what message to send and when to act. So that's basically the gap between the existing system that I was trying to work through. And that would be the exact problem that the Churn Alert AI is designed to solve. Two things basically motivated me in doing this project. First one is the existing churn system will generate predictions, but actually it doesn't recommend any specific intervention actions to the customers. So here, the CSM will actually manually review the scores, decide what to do. And the second one is like in the recent study from a paper from Jan and King, it predicts like the current AI are not real time and it's actually not personalized. So we cannot adapt to each customer specific situation in the moment. So I have built something that bridges this gap. We could see the SaaS companies entirely depend on the subscription renewals for the revenue. So it is basically based on how many customers are signed up and how much revenue a company could make in the particular product. So, for example, when a customer churns, which means like when the customer is not going to subscribe, it will actually affect the overall company revenue itself, and it's just not the one payment. So, research confirms that AI and machine learning can identify churn risk from the data. However, it also acknowledges that most existing systems only predict the what are all the risk that is involved, but they don't act upon it. So that is the main gap this project will be addressing. So this is a related work. So we could, I have analyzed three different papers that was pretty much recent. So as you can see on the screen, the first paper can predict the churn with only a reasonable accuracy that is there. Uh, the Jan and Kang, they demonstrated that combining the user behavior with some data will give some system output, while the other one explored how AI can reduce the churn in especially in marketplaces, which is online. So all three confirm that churn prediction has some solving issues that is there, but none of them actually close the loop with any automated action. So that's when my project came into picture. So this is an AI-based agentic system, which is designed with a multi-agent workflow. I have used LangGraph, where each agent will have a specific role in the pipeline. I used RAG to search the databases, and Grog 3.1, it's for the AI reasoning, and the front end is basically built with React and Tailwind CSS. I've also used PostgreSQL for using it in the production, like we can see it in the end during the demo. So this is the main approach of my project with comparison with the three paper that I discussed earlier. So basically, my project will main goal is to actually predict the real time churn prediction, and it will prevent customers from not renewing. So it's an agent based prediction method that I've used, and we'll be able to monitor the capability in real time. And the personalized intervention here means that I have something called the human in loop. So whenever a customer comes in and you see the risk is more, so you'll be able to see a button in the demo. So the customer manager will decide whether to accept or deploy. So that's the human in touch that's there. So this is the design. So the front end is a React application with four main pages. Like you will be able to see a dashboard, then an admin dashboard, then there'll be an analytics page and a chatbot that is there. So the backend is basically an Flash application with some API endpoints. So as mentioned earlier, my AI agent will have six different nodes, which I call as six different points. Maybe one is for the score, how much the customer risk score is there. Another one is like reasoning as to why this particular customer data which was pulled and why it was recent. Then the human review, and finally it will be the outcome. So for the live data collection, I have used HubSpot, so which pulls up the CRM integration. Then for the database production, I've used PostgreSQL. The most important part is like the human in loop, where every research reaches a customer. It doesn't actually go without any review or approving that is happening around. So this is basically the implementation that I've done. So as mentioned in the previous slide, the main purpose of the front end would be the dashboard, customer dashboard and analytics. The backend and API will be the logic behind how the API services were implemented. The database is mainly for the storage, and for production, I use the PostgreSQL. And the AI agent is used for churn prediction. Langsmith is like monitoring and auditing. The system is then deployed on render with the help of the front end. So I mainly used three like things for the data sources. The first one would be the IBM telco customer churn data set. So as you can see on the screen, it displays the exact real customer record with how many percentages was done. This was basically used to train and test the machine learning models. And then these records were loaded into the DB and then the RAG. The second one is the HubSpot CRM data, which is connected via the MCP integration. So this will actually pull the company records, the properties, how many support tickets it's related to each of this records, and then it will show you what is the risk and what has to be done. So this is the data that has been analyzed. So you could see like the logical regression model was performing the best one, like it based on the analysis that is done upon other three models. The random forest shows a bit lesser, and the other one is less than that. So we want to basically catch as many as risk customers as possible. So the feature importance, there were only few variables that was tested on, which is given on the right side. So these were basically few important variables that was tested to find that. So yeah, we can see the demo here. You're able to see, right? Hello? Hello?
Yes, I can see.
Oh, okay, okay. Yeah, so we will be logging in as there's two login basically. One is the user, another one is the admin. So we'll first log in as the user. So once you log in, you'll be able to see two data sources, which I explained. So one is HubSpot, another one is CSV data. So on the left side in the dashboard, you'll be able to see the live data that is pulled up, like based on the risk. It is categorized as high risk, low, and then medium. So for the demo purpose, I have just selecting the Apex innovation. So these are actually the live data that's pulled up. So here you will be able to see the agent analysis and the reasons why it has been flagged. So now you can click on the agent analysis so that we could see the AI is running on an analysis. So it will then say like clear reasons why this particular account was at risk. and it will also prescribe a strategy what has to be done. So here you can click approve and deploy. Once this is done, it will show what other related risk was there. So once you click on this approve, it will be like this particular company was contacted, and then it will basically tell you like it reads the strategy and HubSpot will be updated to contacted. So when you see on the dashboard, you'll be able to see that it was earlier not written as contacted. Once it is contacted, it will change to contacted. So you can basically mark renewed after the output is confirmed. So this is basically the dashboard analytics page that you can see. So you can also download the report if you want, like what has to be done. Next one is like the CSV data. So this is basically an Excel data. Now we can try logging in using the admin portal. So we just have to give the details and then we have to log into admin portal. So where you'll be able to see a different dashboard that has the portfolio overview, which will give the team metrics and what are all the risk engine configuration that's there. So this is basically the risk engine configuration. The admin will be able to change any score that is present here. So basically every existing tool actually stops at just predicting the churn. So my project will get the basic analysis of what the risk is there and who to contact. So it actually tells the customer success manager like what has to be offered so that the human stays in control of every action.
मुझे कौन
So-
replace करेगा?
So, and then every outcome will be like getting smarter over the product. So this is basically the gap that I was mentioning in the existing system that wasn't there, and my project fixes that gap. So yeah,
Hi,
the
Sai,
next
you have
one.
5 minutes to conclude.
Yeah. Okay. So the next one is the findings. So basically these four things were the important findings that was there. The churn was predicted, so you were able to see the percentage and what are all the variables that was the top predictors. Then I used an AI. So this is a fully retention model, like where you ran an end-to-end integrated system for the very first time, the human in loop as well. So next is to summarize the project. This actually bridges the gap between the churn prediction and real retention action. So it is the first system to actually automate the complete workflow uh, based on these factors such as the daily risk, personalized outreach, and everything. Uh, I can actually call it as a closed loop where every intervention will be feeds back into the system for the future prediction. So this will actually directly answer the research question. So the closed loop design means like all the intervention results which we saw there, like an AI will generate a personalized outreach message. There'll be an like human approval, so you can choose to approve or deny as you saw on the system based on the risk score that is available. So you'll be able to see which customer is going to stop renewing well in advance, maybe like 3-5 days before the renewal happens, so that you could save that customer from not renewing so that the revenue becomes higher. Uh, it's actually an end-to-end automation like model where the HubSpot helps in loading the real customer data that is there, and then the outcome-driven data log. So the future work, we can expand it by expanding the RAG dataset, which will actually give more improved retrieval accuracy. Second one can be like an reinforcement learning, which would be like the layer on top of the existing rule that's there. The third one can be like event-driven monitoring, which might trigger instant analysis based on the threshold. Next is like we can improve this based on like outreach mail that is sent via Slack or an in-app notifications. And the last one, future enhancement can be like to renewal probability or model that's flag and risk. So yeah, thank you. These are the key references basically. Thanks.
Thank you, Sai. Do anyone have any questions for her?
No.
No.
Yeah. Thank you, everyone. So that concludes our applied research symposium session. Thank you, everyone, for presenting your research and your workings. I will end the meeting. Sorry, stopped.